Hi, everyone. Today's lesson is a review for our conics test that's coming up. So let's get started. So the first question is determine the equation for the parabola that has a focus at 0, 2. So let's put a dot there. And vertex of 0, -4. So my focus is here and my vertex is here. Remember that for your parabola or any conic, your focus is sort of cut by the arc. See how it's always going to be inside like that. So I know that's what my graph looks like. That also tells me that my graph is a y equals x squared, which if I were to put that in parabola or standard form or vertex form for my parabola, I'm going to get y minus k is equal to a times the quantity x minus h squared. And a is equal to 1 over 4p. So I will say that some people will write this differently. They do, instead of putting this as 1 over 4p, they put the 4p over here, and they would go 4p is or times the quantity y minus k equals x minus h quantity squared. I don't do that. So, but you're going to get the same answer regardless. So we do know that our vertex is at 0, 4. So remember, this is x, this is y always. Y always goes with k, so this is going to be y plus 4 equals a, which is 1 over 4p times the quantity x minus 0 squared. P is the distance from my vertex to my focus, but also the same distance from my vertex to my directrix, which we don't have and they don't ask for it. So anyway, but I just wanted to make sure you understood that. P, if this is 2 and this is down 4, that makes 6. So P is 6. So I'm going to plug in 6 right there. So my final equation is y plus 4 equals 1 over 24. And you can write out x minus 0 squared, or you could just write x squared like that. All right? Okay. Second question says, write this in standard form. I only have one squared term, which makes this a parabola. So first I'm going to rewrite this. So what I have is I have negative y plus 6 is equal to, moving those two values over, I have negative x squared minus 4x. So I have a lot of negatives. I'm actually going to divide through by -1. So I'm going to get y minus 6 is equal to x squared plus 4x. Now, what I notice is that I do need to complete the square. So half of 4 is 2. 2 squared is 4. So remember, if you add one value to one side, because it is an equation, you have to do the same thing to both sides. On the right-hand side, you've got x plus 2 quantity squared, that factors. On the left, I get 4 minus 6, which is what, -2. And it actually doesn't look like I have a value in here. That 1 in there, that 1 is going to be 1 is equal to 1 over 4p, which basically means that 4p is equal to 1, so p equals 1 over 4. So if I wanted to graph this, it actually doesn't ask me to do that, but I'm just going to do it anyways. It looks like my vertex is at -2, 2. Remember, it's always x first, so -2, 2. That's my vertex. And if I were graphing this, because it's a y equals x squared, it is going to graph up like this. And therefore, my focus point would be 1/4 of the way up, and my directrix would be 1/4 of the way down. Okay. Write in standard form, identify the conic. This, because it's a y squared and an x squared, and you do have a minus sign, it is a hyperbola. Okay. And so we're going to complete the square. I'm going to rewrite this. I do have to complete this square one time because I have a y squared and a y. I don't have an x squared and an x, so I don't have to complete the square twice. All right, so let's see. I'm going to rewrite this. So I have negative x squared plus 4y squared plus 24y equals -35. And so that's going to be, let's see here, don't complete the square here. So negative x squared, I'm going to factor out a 4. So 4 times y squared plus 6y. Because remember, before you can complete the square, your square terms has to be 1. And if there's a 4 there or a number in front of that, you do have to factor that out. So half of 6 is 3. 3 squared is 9. And that equals negative 35. But keep in mind, I didn't add 9. I added 4 times 9, which is plus 36. And so what I have here is, let's see here, negative 9x squared plus 4 times the quantity y plus 3 quantity squared is equal to 1. And for this problem, I needed, well, actually, you can't, I don't have to divide by anything because there's no number here, but I cannot leave this here. So I do know that there's ones under here, right? So the correct way to rewrite this is this way: negative x squared over 1 over 9 plus parenthesis y plus 3 quantity squared over 1 over 4 is equal to 1. And so again, this is a hyperbola. My center is at 0, negative 3. If I were graphing this in the x direction, I would go the square root of 1/9, which is like a third, so very small. And then if I were to graph the y, going along the y, it'd be plus or minus 1/2 up and down like that, right? You would make a box, and then you would put in your asymptotes, okay? And then lastly, you would look at this and go, oh, this value, this is negative. So the negative x, so that means my hyperbola is going to go like, and that's got a touch actually. So that's going to go from here, right? And then it's also going to go down like this. Write in standard form by completing the square and identify the conic. You're looking at the first two terms. They're both positive and they're different. It's an ellipse. So now I'm going to complete the square and find the general equation, or excuse me, that is a general equation. I'm going to complete the square to find the standard form. So I'm going to group my x's. So I have 4x squared minus 24x. I've got plus 5y squared plus 10y is equal to negative 21. I'm going to factor out a 4 out of this, and I get x squared minus 6x. Half of 6 is 3. 3 squared is 9. I'm going to add 9 there. I'm going to factor out a 5. I get y squared plus 2y. Half of 2 is 1. 1 squared is 1, is equal to negative 21. Now remember, I have to still add this back in. 4 times 9, which is plus 36, and then 5 times 1, which is plus 5. So 36 plus 5 is 41, right? And then subtract 21, and I get 20. So what I have here is 4 times the quantity x minus 3 squared plus 5 times the quantity y plus 1 quantity squared is equal to 20. I'm going to divide everything by 20 because in standard form there is a 1 there on the right. I'm going to get x minus 3 quantity squared. This is 20 over 4, which is 5, plus y plus 1 quantity squared over 20 divided by 5 is 4 is equal to 1. Okay. And my center is at 5, negative 1. Remember, it is an ellipse. In the x direction, I go the square root of 5. In the y direction, I go the square root of 2 or 4, which is 2. And I'm just going to connect my dots. There we go. Sketch a graph of these two. Well, this is going to be, it's plus plus, so this is an ellipse. So that means that my center is at negative 3, up 1. In the x direction, I'm going to go 2. In the y direction, I'm going the square root of 6. So up square root of 6, down square root of 6. So I'm sketching this graph. It looks something like that. Not a circle. This is longer. For this one, my center is at 0 because that's like saying x minus 0 quantity, x minus 0 quantity squared. So x minus 0 quantity squared. So that's going to be 0, negative 2. So here's 0, negative 2 is my center. In the x direction, I go the square root of 9, which is 3. In the y direction, I go the square root of 6, which is 2.9-ish, something like that. Up and down. Now, I'm actually not connecting those dots because if you notice this minus sign right here, that means it's not an ellipse. Therefore, you're not connecting the dots. It means that It's a hyperbola. And so you're going to make a little box around here. You're going to put in your asymptotes, and there'll be problems later where we find those equations of the asymptotes. And I need to look at this and say, well, my x squared term is positive. So that means that my graph is going to go along, follow the asymptotes. It just sort of goes along there, okay? A couple of just comments here. I know we haven't been practicing so far to find the focal points, etc. But keep in mind that if it is a hyperbola, if it's a hyperbola, to find the focal points, you use c squared equals a squared plus b squared. And if it's an ellipse, to find the focal points, you're going c squared equals a squared minus b squared. And in an ellipse, a is always greater than b. But in a hyperbola, a does not have to be bigger than b. What you do need to know, though, is you have this axis right here. See the axis that like connects, holds those hyperbolas? That axis right here is called the transverse axis, okay? And the other axis, which like doesn't attach anything, you see that, just kind of is there. That is called the conjugate. Okay, that's weird. Conjugate, okay? Conjugate axis, okay? And remember, focal points are always cupped inside of the hyperbola. We'll do some more problems that you have to find that. Write the equation of the ellipse with a major axis of length 16, okay, and focal points are at negative 5, 0, and 5, 0. I always graph my equations. It is so important to do that. Completely gives you a visualization of what your graph looks like. So here's my focal points, and 5, 0, and negative 5, 0, we've got another focal point here. And so I put the F's there to remind me, because what that tells me is that, remember, my hyperbola is going to do this, right? Because it has to cut those focal points, which means that my x squared term is positive. And that means that my y squared term, right, is going to be negative, all right, because that my focal points have to be cupped by my hyperbola, okay? So we know that already. Therefore, we also know then that my major axis has a length of, oh, this is an ellipse. Sorry, this is an ellipse. Let me erase that. That's not true. Okay, going back, plus, here we go. Sorry about that. That means that this right here, because an ellipse doesn't have a major axis. That was the point. Anyway, my major axis is 16, which means that this distance all the way across here is 16. So that means that this distance right here is 8. And this distance right here is 8, okay? Which means that if I go 8 to the left and 8 to the right, then underneath the x is going to be 64. It looks like these are equally apart, symmetric from 0. So this is just minus 0, minus 0. We know that means that that's a, because my major axis is a. That means that's 2a is 16. It also means that the focal points from here to here, that was 5, right? So that means c equals 5. So in my formula, c squared equals a squared minus b squared. We know that this is going to be 25 is equal to a squared, which is 64 minus b squared. So for this problem, let's see, 64 minus 20. 64 minus, so negative b squared is equal to, what's 64 minus 25? So borrow 6, 5, that's 9, 39. So that means that negative b squared is negative 39. So b squared is positive 39. Cool. Okay. Next problem. The focal points are 6, 0, here's 6, 0, and that's an F, and negative 6, 0, a negative F. Okay, the vertices are this. Write the equation of the conic. So because they're telling me that their vertices are 4, 0, and negative 4, 0, this problem should have told me that it was a conic, that was a hyperbola, because I do have vertices on an ellipse also. But let's look at the vertices here. If I were to graph my vertices of negative 4, 0 here, and 4, 0 here, right? This can't be an ellipse, because if this was an ellipse, my graph would look like this, right? And then my focal points would be outside. So therefore, this has to be a hyperbola, right? Because vertices cup those focal points. So that means that this is in the center because it is symmetric. X minus 0, quantity squared. We've got, we have minus, x has got to be positive because it's on the x-axis. So minus y minus 0, quantity squared, is 1. And what this tells me now is that my vertices here in the x direction, I went for one way. So that means under x is 16. For my focal points, this is 6. Okay, so that means c squared 36 is equal to a squared, which is my positive value. So that's going to be 16 plus my b squared term. So subtract, I get b squared is equal to 20. And I don't square root that. I mean, if I wanted to graph it, I could square root it. But this is just what's underneath here is the square root of, is just that value squared. Okay. Next graph. Actually, we're not going to have any inequalities on the test. But just for fun, let's just graph this. So we're going to go 25x, I'm going to divide by 400. So I'm going to get x squared over, what's that, 16? Yeah. Plus y squared over 25 is less than or equal to 1. And what that means is that graph right here is an ellipse, center 0, 0. In the x direction, I'm going to go 4. In the y direction, I'm going to go 5. I'm going to graph this. It is a solid line, I notice, that because it's less than or equal to. Less than means that I'm going to actually shade everything inside. That's less than, right? Okay. This graph says y is less than or equal to that. That's a parabola. So remember this, if I just had y equals x squared minus 4, okay, watch. I'm going to draw a parabola like this, okay? And then the minus 4, what that does is it drops it down 4 units like that, okay? And so what this is asking me specifically is not an intersection point. It's asking me for an area of intersection. And what this is saying is this is less than or equal to, so it is a solid line, not a dotted line. Less than meaning down here. So where everything is double shaded, and this is the answer, is this part right here, okay? It's all that double shaded area. So that would be the solution to that system. This one says, determine the equation of a parabola that has a focus of -3, 2. So there's my focus of -3, 2. And I have a directrix of y equals 1. So that means that value, that's x equals 1. So that means that my y, if it's y equals, it goes through the y-axis. So y equals 1 actually does this. Watch. Like that, and there's y is equal to 1. Okay, well, that doesn't give us much room, does it? So our equation so far, it looks like, if that's my focus point, it looks like my vertex has to be in between here and here, not touching. I'm going to move this up just a little bit, okay? There you go, so you can see that. There's not a lot of room there, okay? But, so what we do know is that the distance between my focus and between my focus and my vertex looks like it's, if that's 2 and that's 1, it's a half, okay? So that means that, so let's graph this. We know this is a parabola that looks up, so y equals x squared. Then we're going to go y minus k equals a, which is 1 over 4p times x minus h, quantity squared. So it does look like my vertex has to be in between here and here. My p distance, which goes from my vertex to my focus point, is going to be a half. So p is equal to 1/2. So for this value right here, if I were to plug in 1/2 here, this is 1 over 2. So now all I need to do at this point is to figure out, okay, well, how do I find the rest of this value? It looks like my vertex is at -3. If that's 1, let's see, let me redraw that. So if that's 1, it looks like it's -3. So let's see here, -3, comma, and this is where it's a little bit tricky, because if this is up to, so I can't really see that, that's my problem. So up to, so here's my focus point, there's the focus point, and my directrix is at 1 right here. So that means that this has to be in between here. So that's going to be at 1 1/2. So that means that that's -3, 1, and 1/2. So that's going to be -3, comma, 2 3/2. Okay, so now we're going to put our final equation in. So we're going to go y minus 3/2 equals 1/2 times x plus 3 quantity squared. And this right here is my equation of my parabola. So sorry, that was a little bit hard for me to see, but just remember that that's a half down and 1 up. So for my equation of my directrix. Determine the equation of the parabola that has a vertex of -3, 5. So here's the vertex here at -3, 5. It says, oh, and it says it's a parabola. There's my vertex. It says that the axis of symmetry is parallel to the x-axis. So that means that it either does this or it does this, right? And that means because if my axis of symmetry is parallel to the x-axis, it's got to be a horizontal line. Okay, so that means that my choices for my graph are either x equals positive y squared or x equals negative y squared. Okay, now it does say that I am passing through the point 5, 9. So that means that over 5 and up 9 is a point on my graph. It's not my focus. It's not my directrix. It's just a point, meaning it crosses through like that. Okay, so we drew the graph. That's what my graph looks like. Here's my axis of symmetry that does cut that in half. Okay, so what I need to do is start off my equation. It's going to be x minus h is equal to a times the quantity y minus k, quantity squared. I know so far it'll be x plus 3 is equal to some value here, y minus k, which will be y minus 5, quantity squared. So we know it's not this equation here because this is my positive graph here. So, okay, so now what we do know is because we don't have a focus point to find p, because remember this value here is p, 1 over 4p, and I don't have a directrix to use that. I do have this one point that they gave me, for which, ask yourself, why did they give me that one point? Well, the reason is that they want me to plug that in for x and y, because if I plug that in for x and y, I can solve for a. So we are going to have 9 plus 3 equals a times the quantity y, what's y? 9 minus 5 quantity squared. So what we have here is 9 plus 3, 9, 10, 11, 12 equals a times 4, what is that? 4 squared, 16. So a is equal to 12 over 16. What is that? Divide by 4, and that's going to be 3/4. So my final equation, therefore, 3 dots means therefore, where's my equation? Here it is right here. And I'm going to rewrite this right here over here with the a. X plus 3 equals a, which is 3 over 4 times the quantity y minus 5 squared. And so this is the equation of my parabola. Keep in mind, though, people, that if you were asked where's your focus point, you can use this value here, 3 over 4, because that equals 1 over 4p. And you could go, well, that's 12p equals 4. So p equals 4/12, which is 1/3, which means that my focal point is only 1/3 this way, and my directrix is only 1/3 this way. Okay. Find the equation for the conic where the difference between the distances on any point of the hyperbola to the foci is 6. So remember, the foci are located at 1, -2, and 9, -2. So let's graph that. So over 1, down 2, and that's a focal point. And then we have over 9, down 2, we have another focal point. And the distance, so if this is 9 and this is 1, the distance between these focal points is 8. So that means at 1, 2, 3, 4, right here, I have a center, because my center is always going to be in between. And this is a hyperbola, keep that in mind. So that means that my graph, if this is a hyperbola, I'm already knowing that my graph is going to look like this, right? Center's here. So that means that this is going to be x, and this will be y, and this will equal 1. Okay, so we know that so far. We also know that this distance here is going to be, so what did I do? I went over 4, so that must be 5. 4 plus 1 is 5. So that means that that's going to be 5. The center is at 5, -2. So that's going to be -5, and that'll be y plus 2. Okay, because it's on my x-axis, the x quantity squared is positive. That means my y is negative. Okay, so now what we have is the focal distance is 6. So what that means is the distance 2a is equal to 6. So that means a equals 3. Now 3a in a hyperbola is the positive coordinate. That's the positive coordinate. So that means this is my positive coordinate. That means that that's 9. So therefore, I know C goes from here to here, and that's 4. So C equals 4. So for a hyperbola, C squared equals A squared plus B squared. So we have 16 equals 9 plus B squared. So that means B squared is 7. Cool. That one formula is something that you actually need to remember. And that is the focal distance. It's basically saying, your distance 1 plus your distance 2 is equal to 2a. So that's really kind of important to remember. I'm sure you went over that in all of your classes, and maybe did 1 or 2 problems. But anyway, don't forget that. So the next question says, solve the system of equations. So this is a circle, and this is a hyperbola. And so this being a circle, I have 4 to the right, 4 to the left, 4 up, and then 4 down. So we have a circle that goes around like this. When you're solving a system, you're looking for the intersection points, okay? That's your main goal. You're looking for the points of intersection. This being a hyperbola, I'm going to rewrite that, is -2x squared plus y squared equals 10. Dividing by 10, I get -x squared over 5 plus y squared over 10 equals 1. And when I graph this, center's at 0, 0. In the x direction, I go the square root of 5, which is like 2 plus something. And y direction, I'm going the square root of 10, which is like 3 point something. And so then I would make my box like this, okay? And then I would put my asymptotes in. And there we go, like that. And I notice that my x squared term is negative, which means that my graph is actually going to go up and down. So from here, my graph is going to go like this, follow the asymptotes, and it's going to go from here that way and that way, follow the asymptotes. So what's happening now is I notice that I actually have intersection points, but they're really kind of tricky because I don't have a clear view of what the intersection points are. So it's always a good idea to solve this by algebra. So in solving by algebra, you have 2 options. The first option is to solve it by elimination. That's where I add or subtract my 2 terms, to add or subtract to eliminate one of my variables, or I could substitute. I'm going to actually subtract. So try a different tactic on this problem. So if I were to rewrite this, I have x squared plus y squared equals 16. For this one, I have -2x squared plus y squared equals 10. what I'm going to do is just subtract the top term minus the bottom, the top terms. So x minus -2 makes 3. Y minus y, that's gone. 16 minus 10 is 6. I'm going to divide by 3. I get x squared equals 2. I'm going to square root both sides. I get x equals plus or minus the square root of 2. So what that means is this value here is root 2 comma something, and this is negative root 2 comma something else. And this is going to be root 2 comma something, and this will be negative root 2 comma something. And to find that something, I need to plug it back into one of these equations. So I'm going to plug it back into the top equation that says x squared plus y squared is 16. This right here is going to go in there. I'm going to start with 1 because it's going to be the same answer for both, because when you square a positive or negative, you still get positive. So we have the square root of 2 squared plus y squared equals 16. So we have 2 plus y squared equals 16. We have y squared is 14. So y is equal to plus or minus the square root of 14, which means that all my intersection points have root 14 in them, like that, negative root 14, etc. So the points would be plus or minus root 2, comma, plus or minus root 14. And then there's 4 different points of intersection. The next problem, it says name the conic ellipse because they're both positive. Write the equation in standard form. List the components. Finally, let's divide by 36 on all these terms here. So dividing by 36, I'm going to put the x first. I like the x squared first. So this is going to be x minus 1 quantity squared. 36 divided by 9 is 4, so over 4, plus y plus 3 quantity squared over 36 is equal to 1. My vertex, in this equation, this is an ellipse, so that means I have a center. So that means that my center is going to be 1 comma negative 3, so over 1, down 3, so there's my center. In the x direction, you're going the square root of whatever's underneath x, so that's going to be the square root of 4. So that means I'm going to go 2 to the right, 2 to the left, up, I'm going to go 6 up, I'm going to go 6 down, and because this is an ellipse, I'm going to connect the dots like that. Let's see, what else do I need to know? So that means because in an ellipse, A is greater than B, so this is an ellipse, okay? Because of that, A is greater than B, which means that this term right here, that's my A squared. So that means A is equal to 6. So that means 2A is equal to 12. So that means that the length of my major axis is 12. So you would write the major axis is equal to 12. And then that means this value is B squared. So that means B is equal to 2. So 2B, which is my minor axis, is equal to 2 2. And so let's see here. 2 plus 2 is 4. All right, you also need to find the foci. And so the focal points are going to be c squared equals a squared minus b squared. So you have c squared equals a squared. That's the bigger one. 36 minus 4, which is 32. So c equals the square root of 32, which is 16 times 2, which is 4 root 2. So c is equal to plus or minus 4 root 2. Now, you will be, and remember, the focal points are always on the major axis. You will be required to list where they are. Where is that? And so my suggestion to you is always start with your center. If your center is 1 comma negative 3, okay, and you notice that your focal points, because they're always on the major axis, are on the major axis, which is y, that means you're going to add your focus points to this value here. So it's going to be 1 comma negative 3 plus or minus 4 root 2. And so that right there is the equation or the points for my focal points. So those are my foci. Name the conic. So this conic right here is a hyperbola because of the minus. So what we have is, I like the x squared first. So I'm going to put that first. So we got negative 9x squared. So what I'm doing is grouping. So I have minus 18x plus 4y squared minus 8y equals 41. And what this is telling me is that this, I have to complete the square twice. Okay, and remember, when you complete the square, you always have to factor out that number in front. So that's going to be -9 times x squared. And remember, factoring means dividing out. And if I divide out a negative number, that makes that plus. So that's going to be 2x. Now, half of 2 is 1. 1 squared is 1. Factor out this 4 temporarily, and that's going to be y squared minus 2y. Half of 2 is 1. 1 squared is 1. Equals 41. Now remember, what did I just add to the other side? I added -9 times 1, so that's -9. And I added 4 times 1, so plus 4. And so you've got -9 times x plus 1 quantity squared plus 4 times, factor that, y minus 1 quantity squared equals that. I don't know, what is that? Let's see. -9 add 4 is -5. So we have 41 minus 5. So that's what, 36? All right. So we're going to divide by 36 on all values here. And we're going to get negative times the quantity x plus 1 over 4 plus y minus 1 quantity squared over 9 equals 1. And so this looks like my center of my hyperbola is going to be at -1, 1. So graphing it, it's going to be right here, point. In the x direction, I go the square root of 4. So I'm going to go 2 to the right, 2 to the left, 3 up, 3 down. And remember, this is a hyperbola because of the negative sign, right? Do not connect the dots. You need to make a square. So we're going to make a little square here, all right? And we're going to put in our asymptotes, okay? Put those in like that. Okay, where are we at here? So x is negative. So that means that my graph is going to be on the y-axis. So it's going to be, that's a vertice right there. So when you get asked what are your vertice points, that value right there is a vertice. It's a vertice because it connects, it's holding on to my hyperbola, the little, there we go. All right. And then this will go that way, like that. Okay. And then, so now, where are we at here? So asymptotes, meaning from this center, you're going to go up 3 over 2. Remember, it's always the square root of the 9, the square root of the y over the square root of the x, 3 over 2x. Okay. From the center, that's your asymptote. Okay. What else do we need? Oh, we need focal point. Oh, by the way, just a note, this axis that connects your two vertices, remember, that's your transverse axis. Transverse, the axis that doesn't connect anything. See that right there? Just kind of connects the ends of my box. That's called the conjugate axis. J-U-G-A-T-E. Okay. Focal points is going to be c squared equals, let's see, a squared plus b squared. I'm having a little delay in my writing here. Okay, so c squared is equal to, a squared is the positive value, so 9 plus 4, which is 13. So c equals plus or minus the square root of 13. So that means from my center is at -1, 1. Because my focal points are on the y-axis, I'm going to add this value to the y-coordinate to get my foci. So my equation for my foci is -1, comma, 1 plus or minus the square root of 13. Okay, cool. I'm not quite sure if we have enough time for one more problem. Possibly I'm going to continue this for now. I hope that helps, and stay tuned for part 2 if I can do that before the bell rings. All right, thanks for watching. Good luck on your test.